Hello students, welcome to lesson number 11 on circle theorem. The last time we met, we solved a question and I gave you an assignment. I hope you've all done the assignment. Alright, now let's begin our lesson with solution to the assignment. Now to the question. It says, in the diagram below, O is the center of the circle. Line ABC and line CDE are tangents. Angle OBG equal angle GBD. And we're to find I, angle BFD, II, angle FBC, III, angle ODB, and IV, angle BCD. Right. Now, as I've always been telling you, you have to always look for the clues in the question. So in our question, we're told that line ABC and line CDE are tangent. So you have to take note of that. We're also told that angle OBG is equal to angle GBD. You also have to take note of that one. Okay. Alright, so let's now move to our diagram once we've gotten the clues. So first of all, we're to find angle BFD. Angle BFD. So on the diagram, angle BFD is this angle. Okay, angle BFD is this angle. Now, angle BFD is an angle formed at the circumference of a circle. Now, let's look at the chord that formed that angle. So, tracing it down, you realize that angle BFD was formed from the chord BD. That is this chord. So this chord BD formed the angle BFD at the circumference. Good. Now there is a second angle here which is formed at the center, and that angle is 120 degrees. Now let's look at which chord also formed that angle. So tracing it backwards or downwards, you realize that it is the chord BD which formed the angle at the circumference here. That same chord formed the angle at the center. So chord BD formed angle BFD at the circumference, and the same chord BD is forming the angle 120 degrees at the center. So what relationship is there between this and this? You realize that we learned that twice this will give us this. So in our case, half of this will give us this. So when we divide angle DOB by 2, we'll get angle BFD. Okay? I hope you get it. So let's present our solution on the I. So you write your question number. We've seen that angle BFD is equal to half of angle DOB. So angle DOB divided by 2 give us angle BFD. So now substituting, we have 120 degrees over 2 equals angle BFD. So simplifying, we have 60 degrees equals angle BFD. So the answer to the I is 60 degrees. I hope you had it right. Okay, now let's move on to the II. So we're to find angle FBC. Angle FBC. Angle FBC. So this angle from here to here. Okay, the angle here. Good. Now looking at the diagram carefully, you realize that this line here, OB here, is a radius. Okay, and then we're told that this line ABC, is a tangent. Okay, now we learned that anytime the radius of a circle and a tangent meet at a point, the angle formed between them is 90 degrees. So it means that the angle here from here to here, this small angle included, okay, should give us 90 degrees. From here to here, the angle here is what? 90 degrees. Okay, so if this is 90 degrees, then it means that this small angle here plus angle FBC should be equal to 90 degrees. So angle FBC plus this small angle here, which is angle OBG, should be equal to 90 degrees. So when we substitute and simplify, we'll be able to get angle FBC. Okay, but how can we get angle OBG? Because it wasn't given in the question. Okay, so how can we get angle OBG? Good. Now, in the question, we're told that angle OBG is the same as angle GBD. That is GBD. Okay, so this angle. So the whole of this angle, that is angle OBD, is angle OBG plus angle what? GBD. So angle GBD plus angle OBG will be equal to angle DBO. Okay, angle DBO. So it means that when we get the value of angle OBD, that is this angle, and divide it by 2, we'll get angle OBG. Let me repeat it again. When we know the value of angle OBD and we divide it by 2, we'll get the value of angle OBG. Okay, so let's see how to find angle OBD. Now looking at the diagram again, this line is a radius. This line is also a radius. So it means that the length of this is the same as the length of this. Okay, so this side is equal to this side because they are all what? They are all radius. Okay, this is a radius, this is also what? A radius. So they are equal in length. Now looking at the diagram again, we also have triangle OBD. Okay, and because this length is the same as this length, triangle OBD is an isosceles triangle. Okay, triangle OBD is an isosceles triangle. So if triangle OBD is an isosceles triangle, that means that the angle here, that is angle ODB, is the same as the angle here, that is angle OBD. So angle ODB is the same as angle OBD. Okay, so how then do we get it? So once this is 120 and it's a triangle, the sum of interior angles of a triangle is what? 180 degrees. So this plus 120 will be equal to 180. When we subtract 120 from 180, we'll get 60 degrees. Then, since this and this are the same, we are going to get twice of any of them. So when we divide it by 2, that is the 60 by 2, we'll get 30 degrees. So it means that angle ODB is 30 degrees and angle OBD is also 30 degrees. Because 30 plus 30 is what? 60. And then 60 plus 120 will give us what? 180. Okay, so let's present our solution. So II. Good. So we know that from the diagram, angle FBC plus angle OBG is equal to 90 degrees. Okay, so we need to find angle OBG. So we know that angle OBG is half of angle OBD. So angle OBD divided by 2 will give us angle OBG. And then we solved it to get 30 degrees. So 30 divided by 2 will give us 15 degrees. So angle OBG is 15 degrees. Okay, good. So we are not done. So we now have to substitute. So angle FBC plus 15 degrees should be equal to 90 degrees. So angle FBC equals 90 degrees minus 15 degrees. And when we subtract, we are going to get 75 degrees. Okay, so angle FBC is 75 degrees. Good. I hope you had it. So let's go back to the question. Good. So the III says we should find angle ODB. So from the discussion, we saw that angle ODB is what? Is 30 degrees. Okay, it's 30 degrees. So let's look at the presentation. Sorry. So I. So from the diagram, angle ODB is equal to angle OBD. Okay, and then angle ODB plus angle OBD plus angle DOB should be equal to 180 degrees. Okay, so now we are to find angle ODB, and our equation says is the same to this one, so meaning that we can substitute this one with angle ODB. So we have angle ODB plus angle ODB plus this one in the question was 120 degrees equals 180 degrees. So this will give us 2 angle ODB. Okay, and it will be equal to 180 degrees minus 120 degrees. So we have 2 angle ODB equals, when we subtract, we'll get 60 degrees. So now angle ODB will be equal to 60 degrees divided by 2, and this will give us 30 degrees. So angle ODB is 30 degrees. So the the answer is 30 degrees. Good. So let's move back. Good. So to the final question, we have to find angle BCD, which is this angle. The angle here, outside here. Good. Now this angle is the angle between this tangent, okay, and then this tangent. I hope you get it. Good. So looking at our diagram carefully, to get the value of this angle, there are two ways. One way is that you realize that O, B, C, and D, okay, it's a quadrilateral. So O, B, C, and D is a quadrilateral, meaning it's a four-sided figure. And we know that in a quadrilateral, the sum of interior angles is what? 360 degrees. So it means that when we add the angle here to this angle here, from here to here, to the angle at the center, and then to this angle that is from here to here, okay? So this angle here plus this angle here plus the angle at the center plus this angle should be equal to what? 360 degrees. Now the angle here is 90 degrees. The angle here is also 90 degrees. Okay. So this plus this will give us 180 degrees. Alright. Good. Then when we add this 120 degrees to the 180 degrees, we are going to get 300 degrees. So it means that when we subtract 300 degrees from 360 degrees, we'll get 60 degrees. So the angle here is what? 60 degrees. Okay, so that is one way. That is adding this to this, to this, and to this, and equating it to 360. But there's a simpler way also. With that one, we still consider the quadrilateral alright. But you know that if this angle plus this angle, okay, is 180 degrees, then it means that this one plus this one should also give us 180 degrees, because it is 180 degrees plus 180 degrees. That will give us 360 degrees. Okay, so if we have gotten the first 180 degrees, then it means that the second 180 degrees, this plus this, will give it to us. So you can quote that this angle plus this angle equals 180 degrees, and then you simplify to get the value here. I hope you get it. So let's look at the presentation. Good. So Ivan, question number Ivan. So we know that angle BCD plus angle DOB equals 180 degrees. So substituting, we have angle BCD plus 120 degrees, because this one in the question was 120 degrees, equals 180 degrees. So angle BCD is equal to 180 degrees minus 120 degrees. And when we subtract, we'll get 60 degrees. So angle BCD is 60 degrees. So students, this is the solution to the assignment. I hope you have looked at it, seen your mistakes, and you go through to correct them. Okay? Alright, so check through and compare with yours and see where you went wrong, and then make sure you learn it and then you move on. So till we meet again, revise, read ahead, okay, and stay safe. You know that I will never leave you without an assignment. Good. So I have a beautiful question here for you. So let's look at the assignment. Good. So this is the assignment. This is the assignment. It's a beautiful question. I've always been telling you, don't panic when you see the question. Just observe it and admire it. Okay? Alright. So till we meet again. Bye.